All right. Okay, so that is, somebody remind me to turn that off. Sometimes I let it go forever. Those are limits. Now remember, the horizontal asymptote is all about the end behavior. Always was, even in pre-calc. We're not changing that. Okay, so here's the definition of horizontal asymptote. Y equals L. L is some number. It is not talking about when we have infinity or negative infinity. The line Y equals L is a horizontal asymptote of f of x if either this is happening or this is happening. Okay? We already talked about that on the previous page. So let's take a look at our graph, our calculator, and put that in there. If you would, please. Let's see. I got to get it open here. Alpha Y equals. You're welcome. All right, so where's my, why is that not, no, I don't like this thing here. Okay, so you're doing, let's see. Oh gosh, I got too much stuff open, I guess. They can't open both those two things. That's kind of nuts. Maddening. That's just Windows business, right? All right, y equals, so what was it? Alpha y equals, I know it's a fraction. What's on top? X single on top? Yeah. Okay, and then square root. Okay. X. X plus 1. Okay, I'm going to get rid of that 2. All right, let's start with the standard graph. It looks like that. Okay, now, sorry, get my thing out here. So it looks like this. Without investigating it too heavily. Okay. Can you guess what the horizontal asymptotes are? What do you mean negative 1 and 1? You mean y? Okay. So, yes. Y equals 1 and y equals negative 1 are your two horizontal asymptotes. If you want, you can even put them in there to show them. Let's spread this out a little bit. Let's make my y be negative 5 to 5. So you got a little space in there. And then on your y equals y2, let's do y equals 1 and y3 equals y equals negative 1. And then you can see the actual intercepts. Okay? Not intercepts. Asymptotes. Okay. So those are, always takes me 2 tries to get that. Those are your horizontal asymptotes. And this is for this end. So the limit, I have them written down here, as we approach infinity, what's that limit? At this end, 1. That's the horizontal asymptote at the right end. Now I say end, but you know, it isn't ending, so, okay? And then at the left end, your horizontal asymptote is the same as negative 1, okay? At the left end, okay? So remember definition, you can turn around. You can say, oh, if I have that, then I know that's my horizontal asymptote. So remember that. Get that a little. All right, any questions about what the heck we're doing here? So we know enough to even ask a question yet? Okay, let's keep, I want to get to these first, and that's a bonus if we can go there or not today, but that doesn't have anything to do with our homework, so today. All right. These, notice all your examples are at infinity, okay? So, and remember when you're doing the limits at infinity, I'm going to just write it like this. Then that's a horizontal asymptote. Okay, now, how did we find horizontal asymptotes in pre-calc? We called it something. Remember what we called it? No, rational expressions, which if you look through that, they're all rational, as in two levels. Okay? Do you remember calling it the degree thing? Katie says no. So, let's look at the degree of the numerator. What is it? It is 1, because the highest power is 1. Okay? It's coming back, Lydia. The degree of the denominator is what? 2. Okay, now, this is a case of numerator is, the denominator degree is higher than the limit. This is example 1. Okay? Do you remember what that situation was? Remember what the limit was? If you don't, throw up your calculator and anybody remember? 1. That's random.
It's 0 greater, 12 more zero, or doesn't exist.
Okay, yes, there's 3 rules. You're right. But we don't know the difference. Okay, so let's put it in here just to remind ourselves, and then we'll remember the rule, hopefully. All right. Alpha y equals, gives you a nice fraction. You don't have to mess with parentheses. 2x plus 6, 3x squared minus 4x less 1. Graph. Okay, it is indeed 0. All right, so that's the rule. Numerator, denominator is greater than numerator. These are degrees. So way down at the bottom, if the denominator degree is higher than the limit is 0. Okay? These are the same rules except for one little thing because we don't have anyway, the same rules that we use for pre-calc. If you don't remember, you just have to revisit those. Okay. What's the degree on the top, the numerator? 3, because it's the highest power. Degree on the denominator? 3. Okay, remember what, if they're equal? What is it? Is this the ratio? Who's talking over there? Lauren. Okay. If the degrees are equal, then the limit is the ratio of the leading coefficients. So this is number 2. So what is this limit? 5/8. Don't forget, if it is appropriate, you grab the sign with it, the SIGN. These are both positive. Okay, now we won't take the time. If you throw that in your calculator, you're going to get, 0.625 close-ish. It's quicker if you, plus you're not always going to have a calculator. Okay, degree here, the numerator is what? 2. Degree of the denominator? 3. Okay, so the denominator is bigger again, so what's my limit? 0. Okay, remember that means I have a horizontal asymptote of y equals 0. Over here, I have a horizontal asymptote of y equals 5/8. Horizontal asymptote on the first one, y equals 0. Make that connection. Okay, we got one more. I'm assuming the numerator is going to be bigger this time. All right, so degree of the numerator is what, 5? And the degree of the denominator is 3. Biggest one is 3, okay? All right, now, in pre-calc, we had what we call it, wasn't a horizontal asymptote, it was an oblique asymptote. So it was something like maybe, I'm not pretending that I know what this looks like, but say it looked like this, where you had an asymptote like this, and maybe like this. Just guessing, okay? So we're not going to, we're clearly don't have, but let's say we have an oblique asymptote. That means we're either going off and getting smaller and smaller and smaller, or we're getting, so your choices are, if the numerator degree is higher than the limit is this, or of course there's always that, if they go into different directions. Okay, so again, we're going to kind of focus on these guys right here, okay? We're just going to say, all right, let's circle the 2 biggest ones, because what happens is the bigger ones take over, all right? Just like on the playground, the big guy takes over, right? Your little, all right, so you're going to put in this case we have, we're going to infinity, so we're putting in big numbers. So let's say we'll put in 100. 2 times 100 to the 5th, is that plus or minus? Because that's all the difference between infinity and negative infinity is plus or minus. It's definitely plus, okay? And when we put in another 100 on the bottom, that put in the same number, you get 100 cubed times -4, and what's that? So, is it negative infinity or positive infinity? Negative. This is a negative number. I don't really think that that's going to be the case, so. Yeah, let's just go there. Okay. Let's check that one out just for fun, because we want to see what it looks like. All right, I'm plugging in. What am I plugging in here? What are we doing? 2x to the 5th. So clear that out. Alpha y equals, give me that fraction, 2x to the 5th plus 3 minus x over 7x squared minus 4x to the 3rd plus 9. All right. Rapid. All right. At this end, it just looks like it's getting bigger and bigger. There's probably more to that than we know. Maybe not. Zoom out. There you go. That's the piece that we were talking about. As we go this way, this piece is just going to get bigger. So if you just look at the other piece, it looks like infinity, but I really zoomed it out. So this is the piece that this is just going to get bigger as we get bigger this way. I'm sorry, this piece is getting smaller. That's negative infinity. Okay? All right. If we were going to negative infinity, same problem. Limits. Call this f of x. So I'm going to write it again. We're going to negative infinity. This time when we plug in to see if it's positive infinity or negative infinity, we're going to plug in a negative number because that's what's at the negative infinity end. So a negative number, say negative 100 times to the 5th power is negative. So I got a negative on top. I know it's this or this. Okay? I got negative on the top. All right, what do I have on the bottom? Positive. So again, it's going to be negative infinity. And if you look at the graph, see what's happening. There's no more. I don't think that we could look at it and zoom out again. Number 3. No, it's just getting obnoxious now. Yeah, see, it's very good. So All right, any questions about, now, you're going to assume that you're doing this without a calculator. This is just our backup for now while we learn it, but if you know these, this is number 5, I think. You know those 1, 2, 3, 4. If you know these 3 rules, you should be good. Okay? This you have to plug in to see if plus or minus. Okay? Otherwise, it's 0, ratio of the leading coefficients, or negative infinity and positive infinity. Okay, now remember, the given here is that we are going to infinity or negative infinity. This doesn't count if we're going to 6. The rules are not all of a sudden all changing now because we have some new rules. We're going to 6, we're going to 6 like we always were. We can either plug in 6, we can do some algebra to get rid of something if it's a problematic. This page only applies to positive or negative infinity. Okay, so here we go. Always some exceptions. Okay, I'm going to infinity, but what else don't I have that I needed on this other page? A denominator, that's right, a rational expression. So here's what I'm going to do is I'm going to create one. Okay, so I'm going to create one by using the conjugate. What is the conjugate of this radical? Okay, so I'm going to do that on the top and the bottom. I hope you used your conjugate today on the quiz. There was a little opportunity to use that. Okay, and I hope you gave me all your limits until you plugged in, and then you didn't. All right, now across the top, you have the a minus b times the a plus b, and what does that give us, Mackenzie Thompson? It is 1, but what do you get before that? X squared plus 1 minus x squared. Everybody see that? Which is, in fact, 1. She's just too smart for us. Okay. All right. Okay, now we're going to use the degree thing because, first of all, we have a fraction here and we have an infinity. Okay, so degree thing. All right, here we go. What's the degree in the numerator? 1? 0. There's no x's. Okay, degree in the denominator? That is 1, yes. Now, again, we get to take over the biggest one. This is square root of x. Squared is x. I'm not going to worry about this insignificant one. Think about all the people at a concert. Okay, we're not going to worry about that one that's not having fun. We're just like, you just go on. Okay? And then we have another one over here, so don't worry about that. But the degree is 1. X to the first, that's the degree. Okay, what's the rule when the denominator is bigger? So the limit equals 0. Okay? Now, again, if you want to verify that, just because we can, throw in from the beginning, throw in the square root of x squared plus 1 and your square root plus x minus x. Okay. All right, there's your graph. See how it hugs the 0 at the end? So it's completely verified, but, you know, always, come on. All right, so there's your verification of that. That's all we're doing. Okay, any questions on that? So that's create a rational expression. Again, if you notice that you already have your infinity or negative, you don't, then don't go there. All right, this is using a what calculus would consider a common graph. which means you should know how to graph that. Ish. Okay? E to the x, what does it look like? Does it look like this, or does it look like this? First one. Okay, now if you don't know that, that's one of those that you should know. Okay, I get these confused. Well, plug in a couple numbers and you won't. Remember, E is approximately what number? 10? 2 point something. Or 3. Okay, so 3 squared is 9. That's going to put me up here, not 3 squared. 9 is going to put me this way. Okay, so anyway, I know you got a lot stored up there, so make sure you can kind of verify one or the other. Okay, so as we go into infinity, what's our limit? As we go to infinity, as we get bigger and bigger across this graph, what's happening? Right, this is infinity, all right? Same graph. Let's go to negative infinity. What's our thing going to be now? 0. Yep. Say this is going to hug 0. It doesn't come back up. It looks like it does, but it isn't. It's hugging the horizontal asymptote is indeed 0. That's the easiest way to do that. I think we could use other things. I'm just showing you some techniques, and sometimes where the infinity and negative infinity isn't a degree thing, you could maybe create a degree thing, or you just do something else like this one. Okay? Let's go back to this page. Okay. And let's go to this right here. Sine of x over x. All right, so graphs and tables, remember that means a calculator. So let's go there. Y equals, I'm sure it is, but alpha y equals check. Sine of x, make sure you close your parentheses. Make sure your mode is in radians, because every time you do degree, your calculator thinks it is. All right, that is like a blurry mess, so I'm going to zoom. My y's are way too close, so I'm going to make my window negative 10 to 10 and negative 5. Let's see. I want that. Oh, shoot. Yes, ma'am. Negative 5 to 5. Okay. There's your graph. Okay. This really is one of those oscillating graphs. If you would trace, use my thing here, hit trace and just hit and hold down. I can't hold, but just hold down until it bumps over. But you're noticing it's going up, it's going down, but it's super long. Okay, it's barely coming up, but it is coming up, because if you look at these numbers, some of them are positive, and all of a sudden they're negative. But it is oscillating like a wave, but it's so shallow that we're like, yeah, it doesn't really matter. So, if we are looking at this graph, what would we say the limit as we approach infinity is? 0, and you would be right. Okay? What about, while we're at it, negative infinity? 0. What about 0? 1. You're right up there at 1. Now, if you're doing your graph and you're plugging in 1, you're not going to be able to plug in 1. I'm almost past, 0. It's going to give you a blank, but if you plug in 0.9999999, it should give you, I don't know what I put in there, but I don't even, sorry, that's not what I want. I wanted close to 0, not close to 1. Okay, so there's your whatever. All right, so why is this one important? First of all, how am I going to remember this? Because you're going to remember the graph. Okay, way to the back page here now. Here's the one we just talked about. Here's the one we just talked about. Here's the one we just talked about. I don't really, that one doesn't come up that much. Okay. So this, we've already discussed this one on one of those first times we were doing limits, haven't we? I think we did this one. Okay. It comes up a fair amount, so you might want to remember that one. Okay, so here we go. Algebraically. All right, limits, laws apply even when we have infinity. So this over this plus this. We're doing that. Sum of the limits is the limit of the sums. Okay? So I divided because I have a single on the bottom. This one, we just talked about, what is it? It is 0. Okay, what's this one? 5, right. The x's cancels. The limit of a constant is the constant. My answer is 5. Now, I don't know what that graph looks like. It's not anything that you would ever, if you have a calculator, sure, you can plug it in. Let's go to sine of, what is it? 5x plus sine of x. Sine of x plus sine of x over x. Okay, I got a terrible window right now. Let's try that again. Window, zoom 6, standard window. Okay. I mean, who knew that that's what that would look like? But you're approaching infinity, so over here, let's see what's in my table. I got 1. Let's change it to 100. So I don't have to, that was 10, but it looks like 4.94, so let's try 100 now. Hopefully it'll be even closer to 5, yeah. 4.9996, that's pretty close to 5, but it takes a minute to look at that. And you could do the trace too. But again, it's oscillating. Go ahead, Lydia. But it's so shallow eventually that it's like, yeah. You look at this number, it's slowly getting bigger, and it'll pop out right around 5. Go ahead, Lydia. I'm listening.
Okay. So for the table, if it's, how do I get it to be like non-decimal numbers? Like they're like really weird decimals.
They are going to be really weird decimals because it's a sign.
No, but like every time I write it, sometimes
Look at your table start. You have 4.26. That's right. So let's just put a 0 in there. And then, you're talking about your table?
Yeah.
You must have changed it sometime. It shouldn't change until you change it. And remember, this is table set. You might have had a set when we were doing the polar graph still, and it didn't get changed. Okay, so again, this one, algebraic means without calculator. Okay? And this was all done without calculator. I think I'm done. Okay, so, oh, thank you. Where am I? Right here.